Hello. This time we'll continue with the basics of graphings and including, in this particular case, lines and circles. So I'll start with a basic setup where we have initially two different points on the plane, P and Q, and their associated coordinates. As you may recall, for each point on the coordinate plane, we associate an ordered pair of numbers that we call their coordinates, the coordinates of the point. So there lies a question here of if I select an arbitrary point on the line, right, that is defined by these two different points, and let me give it a name, x comma y. It's customary to use those symbols, although these are just labels, just not to be confused with the labels associated with the axes themselves. So the question is this: given a point x comma y on the line defined by the points P and Q, is there a relation between the two coordinates, between x and y? So all that we know is that the point that we have described just here is on the line, but we wonder if we can relate these two numbers, x and y. Okay, so that requires a little bit of investigation, and we'll proceed in the following way. Let me take a look at this. I'm going to provide another point, r. But for this point, I know its coordinates. The coordinates of this point are 1, 3. Now, I want to investigate some relations, but something that I find, and I'm going to mark it with a different color so that we can make a distinction, is this. Let's say that I move in the positive direction of the first coordinate by 1 unit, starting from P. So I land here. And then I want to reach R, but in order to reach it, one thing that I can do is to move in the positive direction of the second coordinate 2 units. And that will place me in the right position. Now, if I repeat the procedure, but now starting from R instead of starting from P, then I move 1 unit on the positive direction of the first axis, the first coordinate, and then I move 2 units up in the y direction, in the positive y direction. Then you say, look, by following this procedure, I managed to move from R to Q by just repeating the steps as the ones that we got from moving from P to R. So, that makes me wonder, because now we have the following suggestion. Note that to move from P to R, we follow 2 instructions. The first one, move 1 unit to the right. Second, move 2 units up But this, as I said, is exactly the same instruction as the one that we get from moving from R to Q. And now look, we can imagine ourselves kind of concatenating these instructions to provide a way to move directly from P to Q. But look, I can make it even shorter because I can say, look, I can do this. I can move 2 units to the right and then move 4 units to up. Please disregard the previous one. And you say, look, if I was to follow this and then this, I will land at that position at Q. But then let's see what happens when we codify those instructions in words. We see that to move from P to Q, we can first move 2 units, right? I'm going to make it short. And 2, we can move 4 units up. So now we kind of see a relation here. If we examine these numbers, they're related. In what sense? Well, in the following sense. 2 is a double of 1. 4 is a double of 2. So it makes me wonder whether we can do the following. If we move, let's say, 3 units right, then move, well, look at kind of the instruction here. If I move 1 unit to the right, I have to move 2 units up. If I move 2 units to the right, I have to move 4 units up. So if I was to move 3 units to the right, the expectation is that I would move 6 units up, of course, starting from P. And if I follow that instruction, well, let's give it a shot. Kind of like this. Move 3 units, then boom, all the way here. And yeah, indeed, in this case, we're going to land at the point 3, 7. And that is a point on the line. So, what seems to be happening here is that there's something that is invariant, something that doesn't change as we move, and is how much we move to the right in relation to how much we move up. So, let me codify it. For each unit, let me put it here, we move right, we have to move 2 units up. It seems like this is enough to characterize the line along with the point P. So let's put it all together, because now it seems like this is enough for us. So how should we start? Well, look, what we have here is that, let's say that I want to reach this point, x comma y, starting from P. The only assumption that I have to make is the following. And now I'm going to use a different color. To move from P to the point described by coordinates x comma y, which is this one that is arbitrary, well, I will have to do something along these lines. I would say, okay, how much do I have to move to the right? Well, I look at the first coordinate of P and look at the difference. So I would say move x minus 0 units, and then just by looking at this, I would say, well, here's the rule that we have. For each unit we move to the right, we have to move 2 units up. So secondly, I would say move twice as many units as we move to the right, but now in the upward position. And then I see, let me put it in this way. So, this is saying that to reach from P this point, I move this many units to the right, and I have to move this many units up. Okay. So this is like doing the following. In the x direction, we move x from 0. In the y direction, we move, well, how much? 2x. Well, I'm just kind of distributing here. From 1. And then that tells me a way to establish what y should be. So we have that y is equal to 2x plus 1. So here we establish the conditions on an arbitrary point, right, that we're given here. And it also says that any point on this line satisfies this numerical relation. The second coordinate relates to the first coordinate in this fashion. And in fact, we can see that any such relation, any relation that has this format, is also associated with a line. Let me put it, that's fairly important. We see that each relation of the form y equals to mx plus b indicates a line on the coordinate plane. Where m is nothing else but this instruction that tells us how much we have to move to the right in relation to how much we have to move up. And this has a name. This is the slope. And B, well, what would be B? Well, B is telling us that from a given initial position, which is located exactly at the point where the line meets the y-axis, right? At least at the label that is indicated here, is that we move up. This is the second coordinate of the y-intercept of this line. No wonder why. This is something that we study frequently. Well, the question remains, is every line of this form? No, of course not. Not every line has this form. And to that, an example suffices. Consider the line that is perpendicular to the x-axis and that crosses that axis at 7. So it will look something like this. Clearly, that line has no slope. But we may describe it just as we did in this fashion, in a similar fashion, because we can describe this line as those points whose first coordinate is equal to 7. In other words, we can describe this line just by indicating that the first coordinate must be equal to 7. Just in the same way that we describe the line that we just have here, right, as the set of points that satisfy this numerical relation in the first and second coordinate in this way. Y is equal to 2x plus 1. Of course, there's an even more general way of describing lines, which I could indicate here. Let me just do it here. In general, a line satisfies an equation of the form ax plus by plus c equal to 0, where not both a and b are 0. So at least one of these two should be different from 0. Okay, so the second thing that I promised is to provide a description for circles. But circles are probably much easier to describe than lines, at least from a geometrical perspective. Because a line is something that is really, really fundamental, but a circle is something that we understand in terms of distance and a center. So what is a circle? So a circle is a collection of points equidistant from a common point that we call its center. So what are the ingredients that we need in order to describe a circle? Well, let's see. We can probably do it in its full generality. And I'll start with a well, with a sketch of a coordinate plane. I'm going to omit some details. And I'm going to provide some just generics, a generic point. First and second coordinate. And then from that, I'm going to draw a circle. So I'm going to fix a distance, right? Imagine this is a ruler. And then we span it. We form a circle. And then we ask ourselves, well, given that this is R, right? R is fixed. And that's like a ruler that is given to us. And then we have, okay, I have a point x comma y on the circle itself, just as we had a generic point on the line. But remember that we were to say that a circle is a collection of points equidistant to this one. Well, I think we can compute distances in virtue of the Pythagorean theorem. How so? Well, imagine that you draw these lines. Then all that we need to know is how much is this and how much is this. Well, what about this distance, right? What is this length? Well, nothing complicated, because it's nothing else but the absolute value of the differences between this and this coordinate. In other words, it is given by x minus x0 in absolute value. In a similar fashion, this one, the length is given by the differences in absolute value of the second coordinates. So it would be y minus y0. But then, by the theorem of Pythagoras, we have this. We know that r squared, which would be given the hypotenuse here in this triangle, is equal to the sum of the squares of the sides of that right triangle. So that would be x minus x0 squared plus y minus y0 squared. But this equation that we have here is equivalent. Since we're squaring here, we can simplify it so it looks like this. When you square a number, it loses its sign, right? A real number. And we make it much nicer. But now that we have it here, look, here we have all the ingredients of the circle. This one is the radius. This one is the first coordinate of the center. And this one is the second coordinate of the center. So, what would be the description of the unit circle center at the origin? Fairly easy. It would be something like this. Unit 1 squared equal to x minus 0, because the origin has 0 as its first coordinate, squared, plus y minus 0 squared, because the origin has a second coordinate 0. But this one reduces to x squared plus y squared equal to 1. So what I have here in this box is nothing else but a description of the unit circle, center at the origin, using algebra. See you next time.